Hi everyone. This is Sanjay, and I am presenting you my hackathon project, which is DataSense E2B, which is basically a fine-tuned model over Gemma 4 2B. So let me tell you how exactly this idea came up and why did we do this project. So currently in the market there is a lot of issues with the compute, right? Like how to make it like process LLMs, huge LLMs are, companies are not able to get compute and all these things, and a compute crisis basically is going on. So to solve this, I have come up with this idea for a very long time, and I am not able to find a proper resource. And this hackathon gave me an idea, which was what if we have a very small LLM that is very particularly talented in a very specific domain. Let's say Gemma 4 E2B, which is a very small edge computing model which can run on very low hardware. Let's say now that is very good at a data analysis. So is it even technically possible, and how is it going to work? If it works, then there is no need to use Claude or GPT for smaller data tasks, right? We can definitely check it if that model is working or not, but your data is completely secure, runs on your laptop and everything. So that's how we started this project to be, and this hackathon has been a good platform for me to complete this project. So yeah, let me give you a few overview of this project, how we did and what are the methods we did. So yeah, technically, like the all these fine tuning works on, like we'll make it write code and execute, and we'll check if it is done or not. But here we did something different, where we created like a sandbox, Python sandbox, and made it to execute the code, check if that is running or not, and make it to run in loops. Basically, that's how we did, and we were facing a lot of issues, like I have mentioned you few here before, and I have showed you the examples. And let's scroll down to the important part. Yeah, so this is what I was saying before. So we have taken the new approach that is going like kind of good in the research area, which is agentic loops. So basically how this works is the model will think, will try to execute, and will generate the output, as you can see in this image. So yeah, that's how we did. I tried to the training platform we did was like, we tried SFT, we tried GRPO, we tried DPO, but all of these didn't work. SFT worked kind of. Then the problem was the training method which we were trying to do is not yet there. So we thought of making my own training method, which is basically EVT, which stands for execution verified tutor escalation. So basically how this works is, we ask our 2 billion parameter model to come up with an answer, and we give it a number of tries. You can go up to 5 trials or 8 tries. Now the model will try to answer in the set of this question, in this tries. In the, if it is able to answer, like first it tried, it got some error, it will go to the next part, it will go to the next part, it will go to the next part until it gets the answer. If it is failing in between, our mentor model, that is a 30 billion parameter model, will kick in and will try to answer the question. And now we'll give the feedback to the smaller model, what exactly did it do wrong. So that's how this exact technique was working on. So you can see student tries, it tries to recover, mentor verifies, and if it is good, it's okay. If it is not able to do, mentor gives a hint, and student tries, retries. So that's how the mismatch method works. And we tried to do this, and we got a bit of success. Let me take you to the evals. Here is a lot more detailed um, examples on how everything work, and all these things. So yeah, so this SFTV v1 is what we are using right now for the demo, but this EVT micro performed better on a set of hard questions that even mentor model which we were trying to use failed. So yeah, you can see here, and the macros, we tried to average, right, like all these benchmarks. And you can see like in the DS bench, it tried to answer one question, but that it didn't able to select the right answer, right option. But yeah, so if you can see, like the model was able to clear these benchmarks, which were pretty good comparing to the base model. So yeah, let me come and show you the demo. I think there's a lot more we can discuss, but yeah. So how this works? So for the sake of demo, we have few data. files ready in the data set. You can see here, which have like added here, or you can upload your files as well. And here you can ask a question, let's say which city has the highest average salary. And when you run the data sense, you can see an execution trace, exactly. So it thought to determine the highest city, I need to load the database, verify city and column to exist. So it tried to run the command, it saw all these data bases types are available, these rows are available. Now after that it tried to drew the salary check and it got some error. Again it thought, it tried again, it got error. Next it tried and it got the average salary. Now with the average salary and city, it did it got the final answer. And you can see in the final tab, so the highest city with the highest salary is SF with an average salary of 9500. So this is how it works. You can try it on the platform, it is running on zero. And let me know, I would be glad if you could give me some feedback on how can we improve this, how do I improve my training method which I made, or any more feedback that I have done wrong or anything like that. I would be glad to help. Thank you so much.